Good evening, guys. Welcome to second session of Tech Club Presents Boot Camp. Today we'll be learning about data science. This whole course is designed in such a way as to get some information about what data science is and all the introduction that's required to start off in your projects. Today, Prajwal Anantrao of FSM will be handling the event. He has got some good things planned for you, relatable stuff. So, if you are a math enthusiast and want to pursue a career in data science, this is for you. And you know the drill from yesterday. If you have any doubt, you can interpret in the middle. And this session is being recorded, and the video will be sent to you later for those of you who couldn't attend the session. And please RSVP yourself in the link provided in the chat box, so we can count the attendance and make use of that. So we'll be starting in a minute. Ritual, I welcome you to take over this session on Introduction to Data Science.
Thank you, Shishira, and good evening, everybody. We'll be starting in a few minutes. Before we start, I'll just give you an outline as to what today's session will encompass. Yesterday, we saw how the static part of web design, HTML and CSS, and how to start up and how to like resolve issues that you encounter along the way. And today we are gonna slightly go off track. Um, According to the course, it should be getting into the dynamic part of the front end. But here now we are just gonna stroll away from it. Like go into the back end, and I'm not gonna go into any sort of technical details, but I'm going to give an outline as to how you can analyze your data, basically whatever application you need, how to uh, correlate data, basically data analysis in a sense. So I'm going to give you guys a good insight. It'll be mostly theoretical, and I'll introduce you to a graphical library of Python, matplotlib, uh, that will like take you through as to how you can visualize the data that you want to process in your backend. I also had planned a linear regression model, like teaching you guys regression, like how to correlate the data within your particular problem. And basically, most problem statements, if you want to find a solution, you will have to process the input data. And I had thought of a linear regression model to help you out with that, but let's see if time permits, like we can go with that, or else like we can get to the theoretical part of how to approach this. I will in no way share any particular algorithm. That is all left to you guys, because I don't want to like make it any disputable thing. I'll just give you an insight of what and all you can do, and any technical thing that I refer to, I will give you guys a link, uh, be it the matplotlib documentation or a tutorial link as well, to get you started off with. So I hope you guys are excited.
That's great content, Prajwal. I'm sure everybody is excited right now. So the session is being recorded, and all the required resources will be shared to you. And let's start off, Prajwal.
Yeah, okay.
And if you have your laptop beside you right now, you can do it parallelly with us.
Yeah, the thing is, there won't be too much of a technical session, and even if there is a technical session, I have some prerequisites already installed, so it's best that you not do parallelly. Like if you already have the libraries that I've installed with you guys, it's fine. Or else It's usually going to be quite a hassle to follow on with me because I have all of the prerequisites installed. If you want, I can show you guys how to do that as well. But that will be with respect to how much time we have. So, welcome to this session, uh, Introduction to Data Science. Let's get right into it. I've already like given you the. So what I'll be covering is basically a general introduction as to why they call it data science and what it exactly encompasses and why we have to manipulate the data within our backend as to solve our problem or provide an authentic solution. And then I'll talk a little bit on regression as to how when you have multiple parameters within your backend, then how to manipulate it and all. And then a small coding session. We'll see what and all we can cover up based on the time and resources available. So if you guys have any sort of doubt, you can just unmute and interrupt me. I don't mind, or you can just post it in the chat. I won't be visiting the chat often. Shishira, please notify me if there are any questions.
Cool, sir. Cool, Prachur.
Okay, so let's get started. So basically, what is data science? I see data science as a four-stage process where you filter, organize, analyze, and visualize data. So when you go into any project that you have taken up, the main aspect that you'll be working on will be the raw data that you collect from the particular field. uh, for example, if you select something like a health field, okay, suppose you're being something like a medicine supply, you're running a medicine supply chain and you want to know which locality consumes which sort of medicine and supply the appropriate amount of medicine to that particular locality. You don't want any of the medicine to go to waste. So what you do is you collect all the data from all the localities as to how much of this particular medicine is being consumed. So when you gather a lot of data, you get a lot of unwanted data along with it, some which may not be necessary. What you have to understand is that when you're trying to prepare your solution, you'll have to filter out all these unwanted data and only pick out the actual data. That part is the filtering in data science. And then you'll have to organize it. Organize it in a sense, you'll have to make sure that, for example, uh, if the consumption of the particular medicine in the problem statement that I've picked, if that particular medicine last how much of it has been consumed in the year 2020, how much of it has been consumed in the year 2019. For the same medicine, there may be various parameters that can be influential on how much you must supply to a particular locality. So you need to make sure that you have all the parameters organized in such a way that you can correlate each of the parameter with the parameter that you are picking on. Here is the amount of medicine. So amount of medicine with respect to the patient, the patients that are in need of the medication in that locality, or with respect to how much it has been consumed per year. You have to be able to look at all the angles and you will have to organize it. And the third stage is analysis. So in when you're analyzing data, this is where you start building functions to correlate. For example, there is this oh, sorry. There is this again. When you take the medicine example, in 2018, some maybe 2,000 units of data, 2,000 units of medicine was consumed, and in the 2019, some 1,500 units of data, units of medicine was consumed, and in 2020, say 3,000 units of medicine was consumed. So in 2021, I want to know how much units of medicine will be consumed. So if I can correlate these two parameters, the year and with respect to medicine, I will be able to deduce a relationship. I want to make sure that whatever relationship that I deduce will have to be something that is practical. So I'm just gonna like show you guys. a new window. Okay, just a minute. I'm just gonna show you guys a new relationship. So I'm going to say I have, sorry for the scribbling, but this is the say amount of, I mean, sorry, this is the year, and I have amount of medicine consumed. So I have here probably in like 2018 some amount, 2019 in some amount, and 2020 some amount of medicine has been consumed. Let's say this something like 100, 200, and so on. So I have statistics like this. So if I want to predict in the 2021 mark, how much medicine will it be, this much consumed, or will it be this much, will it be this much, I'll have to deduce a relationship which follows this curve. If it doesn't follow this curve also, I have to deduce a relationship in such a way that it will it will be something that is a satisfactory solution to the end user, to whatever solution that you're promising. Because year amount of medicine and year are not the only two parameters. You have multiple parameters that will depend on the amount of medicine that is used. So if I just follow this curve, say it lands over here, this may not be a satisfactory solution. So the analysis of why this is not a satisfactory solution and what you should do to bring a curve that will give you a probability of, a more correct probability, is the analysis part of data science. And then visualizing is just graphical representation. Usually when you're doing your projects, you expect the user, if you expect the user to believe you, if you just say okay, in 2021 he needs 300 units of medicine, the user may need an explanation, and you can show this visualization in form of graphs, charts, or bar graphs, or different kinds of visual effects, and you can give a better explanation. So that is the basic idea, or the basic idea behind data science. So let's see why we exactly need manipulation with another example, with the house pricing example. For example, I have a house. I have a house in a locality, and I want to sell this house. There are multiple houses in the same locality with many different features. As you guys know, like the feature can be like 3 bedrooms, 2 bedrooms, based on bedrooms or based on kitchen or square footage. There are multiple parameters to look at it. So I want to know what my house is priced at. This particular house, if I want to sell it, I want to know the best price that I can sell it at. I have records of each house that has been sold here before, and I want to set a price which is best satisfactory in my locality. So let's, again, there are many features, say like square footage of the house. If the house is bigger, yes, obviously it may fetch a better price. But again, it depends on many other things like number of bathrooms, number of bedrooms, etc. The model, whatever that you want to build, it should determine the price of your house, which again, which will keep in consideration all of these particular uh, houses and all of their parameters. So I'll need to analyze each and every parameter with respect to the price, and then I'll have to give a prediction on my own. So how do I start off with that? A linear footage, let's take square footage, right? So I've just taken some random data like 1000 feet, 1500 square feet till up to say this, and I've just given a price, a random price limit of how it can be. Now if I say that, if I can just say my house is 3000 square feet, okay, my house is 3000 square feet, and there is this guy with 2000 square feet house. Okay, so if my house is being sold at somewhere like 1.5 lakh rupees, And if this guy with 2000 square feet, if he has, he should have a price of somewhere like 1.3 lakh rupees based on this particular relation that I've drawn. But what if this guy has his house priced at 1.5 lakh rupees himself? Then you might be wondering, oh, okay, my house, how can it be, priced so low? Or another case would be that when you have your house at 3000 square feet at 1.5 lakh rupees based on some other guy having the same rate. Suppose another guy with 3000 square feet is priced at 1.5 lakh rupees. But you know that your houses have better parameters than him, and you would expect a natural raise in your price. So you will not be satisfied with this single linear relation built. This is not even a linear relation. This is just a graph plotted between data. So you would expect a relation which would encompass, which would try to like solve all those problems. So you may not in the in the end you may not be satisfied with what price that has been set. So how do you tackle this problem and consider all these parameters and build the best price possible? So one technique that comes to mind is regression. So regression is just basically just a statistical method to generalize the relation between two or more variables in the data set. Again, as I told you, I'm just going to keep scrapping up paint this. So I have square footage. I have number of bathrooms, number of bathrooms, number of bedrooms, and I have kitchen stuff. I don't know. You guys tell me. So all of this must be correlated with the pricing of the house. Pricing of the house. So, oh, okay. I want to make sure that all these are appropriately related to the pricing of the house. And in the end, I want to find a relation, a graph where I have the price. Oh, sorry. Just where I have any of the parameter, say square footage. If I have something like square footage and if I have price, so even if I have some graph like say like this, I want this graph to consider all these elements and then determine the price. So it should be not only square footage, it should also be number of bathrooms, number of bedrooms, all those parameters basically. So in the end, for my given details, it should be able to accurately predict a price which I am satisfied and which is realistic. If it isn't either of those, if it isn't both of those, then your prediction model may be wrong. Or whatever problem statement you're trying to solve, if you give a solution that is not satisfactory or real and realistic, then you may land into trouble. Uh, so it must you must not try again you must not try to overthink or underthink a relation. So what do you mean by overthinking or underthinking a relation basically? So I have this linear model, right? Square footage as to house. So if I try to make a relation, I have the same thing here. If I try to make a relation which gives me a straight line, if I have a straight line, that it's a linear model basically. As you can see here, there is already scope for error. The actual value of the house is somewhere like 1.4 lakhs, whereas the statistics is showing somewhere close to 1.2 lakhs. Is this something that is an acceptable model? That is something that depends on what you make of it. uh, when you say you're overthinking a model, you mean that it must always be a perfect model. That means here I am not getting 1.4 lakhs, so my model is wrong. So these kind of overthinking is usually not recommended, because when you build a model like this, you have considered all the other parameters other than square footage also. So even if your model may be like at 12 lakh, I mean at 1.2 lakh, this 1.4 lakh may be showing because it has other parameters which are better. So usually if you want to bring a relation in the 2D form while considering multiple parameters, it may need not always point to the exact solution. If you're trying to overthink it and bring it to this exact solution, you will land up with something like joining the dots with a given data set, which may lead to erroneous output when you give some other foreign set. That is, when you try to input some random data, it may show when you say 3000 square foot, you may end up somewhere here or somewhere here, but it will be showing here. So that sort of erroneous thinking is when you overthink the parameters and you try to fit every point. This kind of curve fitting is called overfitting. Then again, you can also underthink the thing. So there may be multiple parameters and your recommended curve after you build it may go something like this. But then again, you're lazy to try and correlate each and every parameter within each other, and you just go and fit a straight line. When you do things like this kind of a thought process is called underthinking in data science. So you don't have to, you shouldn't overthink or underthink a relation. In either cases, you will lead to erroneous output. What you have to do though is try to make sure that your function, when you have your solution, that solution is realistic for all the parameters. For example, you can just for checking purposes, you can have just a sec. Um, for checking purposes, you can just draw multiple relations. Like this is with respect to square footage, this is with respect to number of bedrooms, and this is with respect to number of bathrooms. And the actual data will be something like this. Okay, and your entire solution with all these parameters in here, it should give you a realistic graph which kind of like merges all these graphs together. So when I say for a particular square footage, it should point to somewhere close there, close by, if not exactly here. If not exactly in the same point, it must point somewhere closely, right? So that is how you should have a mindset when you're doing this. So now let's go to a bit of a coding session. Let's start off with one of the Python libraries called matplotlib. I'm just gonna put up uh, the matplotlib documentation link right here in the chat box first, like to get started. I hope when you guys are trying to code with me, you have if you guys are trying to code with me, you should have the prerequisites. Like you should have Python, and you should have VSE installed, you should have Python in, and you should have this matplotlib installed. I'm just gonna go here and show you guys the actual website. You can easily see installation guide. Installation guide, you just have to go to the terminal and put out this command. You should also have the Python package manager pip. So if you don't have it, just install. I'm just going to show you a couple of programs as to how you can uh, run matplotlib. So I have this command. This is the importing command. If you guys are new to Python, I hope you guys are well equipped with C. It's something like hash include command, this particular import statement. So from matplotlib, import pyplot as plt. Pyplot is the is the library which will be using to plot graphs visually. So I have some data X. an array of data 1000 3 2000. This is a list, 1000 2000 3000 4000 5000, and y as something. This is the house pricing, same example, from the house pricing example, the same graph. I'm just going to execute this code and show you what it does. So in the terminal, so here I have shown plt dot scatter of x comma y. So when I say scatter, it is just going to map each and every element, and it's going to show every point of this x comma y as shown here: 1000 to 1 lakh, and 2000 to 1.4 lakh, 3000 to 1.6 lakh, and so on. This scattering function you can just use to, check your input data or test data. And then I'm going to execute one more file where I've just I made it a bit cleaner. Here I've actually plotted x comma y. Here the plot function will basically draw a line. It will not just represent the point, it will also connect those points. And here I've given some other attributes like plt.title, plt.xlabel, plt.ylabel. You can all visit this documentation to learn more about each of these functions. I'll not try to get too much into the technical details. And this plt.show is the command which you'll have to have at the end of every uh, uh, you know like uh, file, because you'll have to show this. This is just for showing you guys, but when you're doing function calls, there'll be a different procedure for this which will be taken up sometime further ahead. So python plot1.py, here we have the same thing. The lines has been plotted, the square footage with respect to house price, and I have just one shiny title as house price. You can basically go ahead and check through with this. For large data sets, what this does is that you can analyze bits. You can analyze this into bits and pieces. You can zoom in, zoom out. You have other functions and all that. So you can have this, and if you want to display the static part of this, you can basically just press save the figure, and you can use the figure as the static image shown yesterday. How yesterday it was shown, how you use images in your front end. But if you want a dynamic one where you see live data being manipulated and displayed here, there is a totally different procedure which will be covered sometime in the future after the dynamic front end is introduced to you guys. So this is basically the matplotlib library. I'm also going to send a link to the tutorial videos. If you guys want to get started to matplotlib, there's not only graphs, there is also stuff like bar graphs, and pie charts, and many other videos. There is a series of 10 videos which will get you through a lot of different varieties of representing data and manipulating it as per your needs. So this is about matplotlib, and I wanted to take a small session on linear regression, but unfortunately, I'm facing some technical issues, so I won't be able to exactly show you guys any regression models in particular. But I can give you guys an idea as to what and all you'll need. You'll basically need these modules: NumPy, Pandas, and sklearn. The documentation links for the same will also be given. Uh, I'll just post the matplotlib tutorial link here in the chat, and I'll also just send you guys the NumPy documentation. The NumPy module is basically for used for converting lists into arrays. In Python, usually in C, you guys call these arrays, right? For in C. In Python, these things are termed as lists. They are not in the array format. They'll not be treated as arrays. But when you're performing linear regression, you may want to like convert them into arrays. So what the NumPy module does is it gives you that option. I'm just gonna post all these links here. You guys, feel free to uh, go through all of those and like learn. And there is also one more uh, library called Pandas. I'm just gonna go through its documentation as well. Pandas is basically again like this is just for structuring your data, whatever you have, right? So I'm gonna post this as well. And the major part for your linear regression module will have to be the sklearn, the scikit-learn library. So what scikit-learn does is it has its own uh, functions which basically perform linear regression for you. You just see all of these techniques. It has regression, clustering, classification, all that stuff. Regression will probably be the best approach, but you guys can feel free to handle data in any of these methods you want. It has functions that can readily process your data in any way you want. You just Google however, whatever you want exactly, and you can be redirected to the scikit-learn page where it will show you exactly how you can do it. As for the regression part, linear, I'm just gonna show you. I'm just gonna send you guys a video link tutorial as well. I'm not able to directly share live with you because my system is kind of hanging. So what I say is that if you want to learn about the algorithm, if you want to learn about this algorithm, this is one of the uh, go-to videos, linear regression and how linear regression works. Just visit that video and like you can learn about it and you can implement it as well. So that's about it, guys. Thank you for listening. It was shorter than I thought. I should have actually been I should have actually practically shown you guys how a regression model works, but I have some technical issues. In a future class, maybe I can get to the same, and after the dynamic front end has been introduced to you guys, I'll also show how you can represent data and manipulate data uh, on your website or on your mobile application. So thank you for listening.
Thank you, Prajwal. Hope to get more information from you very soon. So the part two of this lecture, what Prajwal took today, will be right after the part two of yesterday's lecture. So that's how we have planned it. It's all in hierarchy. We start from static pages and we introduce a bit of application to you, and then we make learn to make the pages dynamic using databases and all that, and bring in more and more application tools into your development. So thank you, Prajwal. That was a great session, a great introduction to what data science is all about. We learned about regression, by the different uh, reasons why we use data science as such. Also, the feedback link is shared on your Google Meet session, Google Meet chat. Please fill it out as that'll help us to motivate, keep ourselves motivated, and make more quality content in the future. So thank you, Prachula. And if anybody has some doubt, you can unmute yourself and ask. Does anybody have any doubt? Okay, I guess there are no doubts. So we'll end the session today. And we'll be meeting tomorrow with Karthik Ravi Shankar and Aditya giving presentation on version control using Git and Git pages. That's going to be quite a good session tomorrow, and hope you all joined that and support us. Thank you guys. I guess we'll be ending the session today. Thank you, Prajul, for the amazing session, and we'll all see you tomorrow. Thank you.